This is lecture 3 of Data 100 and Data 200. The topic is random variables. But before we get started, let's recap the last lecture where you learned about sampling. And formally, you learned about why we need to sample in the first place, what it means for our sample to be biased, and how to prevent these biases in the first place, and what a sampling frame is, and why choosing a good one is very important. You also learned how to compute probabilities from samples, in particular binomial and multinomial probabilities. So in this lecture, you're going to learn about random variables and their properties. Now there are many different ways that we could introduce random variables, but we're going to study them directly as they relate to sampling. So what is a random variable? A random variable formally is defined as a numerical function of a random sample. Now you might recall from data 8 that a numerical function of a sample is a statistic. So a random variable, another way of referring to it, is as a statistic. Now why is it random? Because the sample on which it is a function was drawn at random. Why is it variable? Because its value depends on how the sample came out. Now in terms of how we denote random variables, we typically denote them with uppercase letters late in the alphabet. So for example, X, capital, and capital Y. Let's look at a concrete example to help make this clearer for you. So here's a population. We have blue people and not blue people. So we can say that S, our sample, will be of size 3, and X will be the number of blue people in that sample. So X is a random variable. Now let's draw a sample. So our first sample has one blue person. So X of S is 1. Our second sample has 2 blue people. So X of S is 2. And our third sample has no blue people. So X of S is 0. Now, if we were looking at this from a math class point of view, we'd say we have a function. It has a domain, which is the set of inputs, and we have a range, which is the set of outputs. So in general here, the input to a random variable is a sample, and the output is some function of that sample. So the domain here is all samples, and the range, or outputs, is all real numbers. So a random variable is a function of the sample. So a function of a random variable is a function of the sample. So it itself is also going to be a random variable. Now, if you create multiple random variables based on your sample, then functions of them are also going to be random variables. So as an example, let's say we have x sub 1, x sub 2, all the way up to x sub n. Those are all random variables. So all of these will also be random variables. If we have x sub n squared, that's a random variable. Similarly, if we have the average function, 1 over n times the sum of the x sub i's, that's also going to be a random variable, as will all of these other functions also be random variables.